Hello. Uh, in this video, I'm going to talk about inert processes or operations. Elaborate a little bit more on that. I touched on it on the last video. I wanted to show some features of it and kind of explain how you can use them in the same way that you can use the active operations as a word, and I could show some interesting uh, um, things about that. And then I wanted to talk a little bit more. So the next video, I'm going to talk about something I've been calling a semantic package, a way to contain or encapsulate various structures in monadic theory and be able to uh, essentially use them for like input or output. So in functional programming or thinking they would call it a side effect. So it actually be able to incorporate side effects into the theory using those packages. And maybe it's not to that point where it'd be something that would be considered that, but that's kind of how I'm seeing it in my mind right now. It's still being explored. It's fairly new in my use of it, and I'm trying to understand a little bit more. And then the video after that, I plan on working on looking at the graph part of the representation in monadic theory. I wanted to kind of go and see what the graphs look like and like how you can look at it in different ways and that and how I use them and stuff and to understand these monadic structures in different ways. And then the later on down the road, I'll talk about the strings part representation in monadic theory, and the whole idea is once I'm done with the semantic packaging and whatever mechanism I need to utilize that process inside the Moo universe, then I want to kind of like take all these different pieces and kind of bring them together. And part of the video with the graphs and part of the video with the strings will be you'll be able to see those in action, and you'll be able to see that view or tal equivalency is what I've been using of those between the different ways to look at monadic theory. And then I believe that would probably be a stopping point for the creative part and more of the starting point to start tying it all together and making it a little bit more. I know I use the term multiple times, formal. I want to make sure what I'm doing is actually making sense and whatnot. Uh, so I'll start with the inert processes and then we'll go from there. All right. So I'll use the activator operation, which is alpha, and I've been calling it the inert activator because it makes sense, right? So, and essentially what makes it inert is this index, because you're basically turning this process into a monode, like I explained in the last video. And as a monode, it doesn't do anything. It has all the features and properties of a monode. You can turn it into a polynode using the gamma operation. You can bind it with another monode, and it can be an ordinary monode or another inert process or operator. Any of that could happen. It acts just like another monode, right? Until you put the and I've been using both these terms, and you'll probably hear them both. Either a processor or a catalyst, and I like them both. And I know I come up with all these dual terms, but for me it makes sense. So So, being that this is a monode, then this adicity follows the same rules. Where if it's a zero adicity, there's no no binding to it, but you can turn it into if you use a binding operation, you can turn it into a polynode. Or if it's one through some definitive number like 3 or whatever, then you have that many arms or that much adicity, however you want to look at it. And if it's infinite, then you have an IEM. And I told you every once in a while I'll be coming back to that idea that there's an infinite number of arms. So you can either take and use as many as you want or lose as many as you want, as long as it doesn't it doesn't matter. The value of it wouldn't matter, so it doesn't have an effect in that. So it has all those different features. Well, here it's kind of the same idea. So when this is catalyzed by this, it basically becomes an actual active operation, an activator of. Well, we know when you're using this on this, that means this has to be operating on something, right? That was the whole idea behind this operation. And in a way, you could actually kind of think of it as like a very temporary binding between these two. I haven't really gotten into the mechanics of that part, but you could literally look at it that way as like it's a temporary binding, and then once it's all done, the binding's gone. Poof, right? So you get this activator here, and then that mu becomes the default because there's nothing else for this to operate on. So poof, and I showed this all in the previous video. Oh man, I'm gonna choose H. So yeah, you kind of once it's all done, it goes through each process, and then poof, you get a final result, which is a monode that has zero adicity. That's it, and it all stems from that. Now, now this could happen with any of the operations, right? We could do a beta, so we'll do a beta, and we'll go through the whole same thing, right? So yeah, there's your monode, nothing, and we do this. Still nothing. So processor catalyzes whatever catalyst works on this inert operator, and then from there you get a beta of a mu, which is simple enough. I've showed in previous videos when you try to bind mu, well, it just gives you mu. Doesn't do really nothing, right? Kind of absorbs back into the space of the mu universe. So that's that, and any of the operators can become inert operations or processes, or however you want to look at it. And now, with that idea, I wanted to kind of go and explore, and I've done this in a way early video, the idea of a word. And a word is just kind of multiple operators or processes in line. Well, we could have something like this, right? We could have three monodes that exist. We'll call them IEMs for now because I don't even mess with that adicity. There's no point to that in this context. So, all right, say we got these three activated monodes, IEMs, and wow, we're going to process them. We're going to use a processor on them or catalyze or whatever. Boom, right? So as I showed in the previous video, what happens when you create a word? Well, as we process this, they all become active operators. They lose the index because they're no longer monodes or inert processes there. So that gives you, and as we know, since we're going and we're trying to use these processes on something, if there's nothing here, if there's not a monode there or an inert process there to actually work on, we know we're working on them. And we'll put it in parentheses because it just, make it so it makes sense. So now, as I showed before, and this actually is kind of simulates or emulates the previous video where this operates on that, has a resultant, that resultant gets operated on by that, and then that resultant gets operated on that. So we get, and I'll just do it one at a time right here and kind of show you linearly down, right? So we're going to do the alpha on there. When we do that, yeah, we'll get that. That'll give us our first thing, right? And I'll just use, age. Gives us a monode with zero acidity, right? And now we can use an alpha. So that was the first alpha. Here's our second alpha, right? And that'll be on that monode with zero acidity, right? And then that gives us the beta on the resultant of that, because you're using an activator on that, so you're giving it more acidity, so you get a beta on this, which then, as we know, becomes this self-binding monode of H, because it bound to itself. And that's the idea behind it. So you use this, and it basically catalyzes each one of these, makes them active, and then these active processes or these active operations start working on the Moo universe. And then as it goes along, it gives you a final resultant, but it goes from one resultant, and then that next operation goes on to that, uses that resultant, and it's, like all the way down. So, and the final product is that self-binding of the monode. And that's really the idea behind a word in of inert processes and stuff. And there's not really much more to elaborate on that. I feel like a lot of this is intuitive. That's why this was really, really easy to do, to take and build on and build on and build on. Because I feel like each section is kind of intuitive in the sense. It's like, oh, that does make sense. Oh, that does make sense. And I remember when I was first exploring when I talked about in the early video that I worked with a professor, and I was exploring ideas with him about Peirce's thinking and ideas and that, and then Bill's interpretation of those ideas and stuff, and then having those conversations with him, and how it kind of like slowly formed a seed in my mind. And then from that seed, I just kind of like explored. And if anything, I'm very persistent on exploration. And year after year, I just kind of explored the idea more and more. And then it started to build up and start to make sense. Lots of notebooks of just like doodlings that are like failures and ideas that just like, oh, okay, well, that's cool, but that isn't what I wanted. And then it finally came down to where I've honed it into this idea of monadic theory, and it's been actually quite, like I said, a enjoyable time for me working on this, and as I keep exploring more. But I think we're getting to the point where we need to start simplifying certain things and start, kind of reducing any addition, different components, extraneous components into the theory. I think I'm going to just now focus on after I do the semantic packaging. I think I'm going to start focusing on just putting it all together. Be quite a challenge, but I'm pretty sure I'll be able to do it. Hopefully, if it is a sound enough theory, if it can do what it says it's doing, and if it makes sense, and if it's logical, coherent, and that. I mean, for me, intuitively, I want to say yes, but there's still a lot of things to be looked at, and that to see if it's not just something neat, but not very um, rigorous and such. So those are things I'll have to address as I approach this more succinctly in the future. But yeah, that was the whole idea behind inert processes and operations and that. And I think if you see the value in that, in how you could build complete structures, have them in stasis where they're all inert, and then, like I said, start that catalyst and watch it just kind of start to operate on each different resultant from the previous process, and so on and so forth. And I didn't really touch much on this, but I probably should. You could look at a resultant of everything in parallel, like concurrently. Um, it's not really built in. I kind of got more of a linear thing where it's where each. I mean, you can see that you just seen the discrete time steps, right? So it could also be more that there's a concurrent thing where processes are happening at the same time, a parallel processing scenario. But that would be a little bit later on when the theory is more developed and able to handle that kind of thinking and a way of representing processes in general. And I think referring back to process calculus is probably a good way to go about looking at concurrency and stuff when it comes to these operations in monadic theory. However, I'm trying to also abstract it away from the computational part of it and look at it more in the abstract sense to where you can do this in this universe. So maybe concurrency is something you'd have to like build into the system itself. Just interesting questions to explore in the later future. If you're watching this video, thank you. Appreciate it. And if you have any questions, please ask them. I'll do the best I can to answer them. So far, there's been no takers, and I'm okay with that. I'm okay if people do ask. I try to understand this the best as I can, but I easily could be making mistakes that I'm not seeing. And any rational person would agree that we can make mistakes even when we're so certain. Well, thank you for your time. All right.